And exploring conic sections. So your objectives for this is you need to know how to graph and then identify the different types of conic sections. Conic sections is just a broad category topic for parabolas, circles, ellipses, and hyperbolas. So those are the 4 specific shapes you're going to be dealing with. And on your formula sheet, you have circles, parabolas, ellipses, and hyperbolas. So they'll have all the formulas that you need and a reminder of what kind of shapes we're going to be dealing with. These just show you where they get that term from, so you can get the circle, the parabola, the ellipse, and the hyperbolas by intersecting a cone, which is why they're called conic sections. All right, so number 1, how to graph a circle. You've been typically using the graphing calculator to graph things this semester. These ones, it might be easier for you to graph by hand. By making a table of values is how they're going to be doing all of them. So they have the equation. And to get their graphs, they've chosen x values, inserted those into the equation, and then gotten the y values. You can still use the graphing calculator to graph these, but you need to solve for y. So you would need to subtract x squared to both sides, and then take the square root. And when you take the square root, you get the positive and the negative. And then you need to enter both of those to get your circle. Okay, so if you just do one, it's only going to graph half the circle. You need to have both the positive and the negative square root. Okay, to get your circle. And then if you're going to graph them by hand, you can use the equation. When you're choosing your x values, you want to use 0 and then some positives and some negatives. So then you would then plot the points. So when x is -5, y is 0. 1, 2, 3, 4, 5, y is 0. When x was -4, y is a +3 and a -3. The pen's not cooperating. It doesn't want to be a circle today. When x is 0, y is +5 and -5, and you can use that to kind of fill out your graphs. Keep in mind the symmetry of these shapes. That'll help you do some shortcuts when you're trying to graph them. Okay, ellipses, kind of like a circle, but just a little bit more oblong. Its formula, they have 9x squared plus 16y squared equals 144. Same thing. Where they're getting this table is that they're choosing values for x. Notice they do 0, some positives, some negatives. They're substituting that in and finding y. You can graph this as well on your calculator by solving for y. Okay, so y squared equals over 16, then we're taking the square root. So y is going to be plus and minus the square root of -9x squared plus 144 over 16. You don't need to simplify anything. The calculator will graph it correctly. You don't have to go and find the square root of 144 and then to do the 9 divided by 16. You can save yourself time, just enter it as you see it. I need an extra set of parentheses here though, because we have divided by 16. And then the negative. And then you can graph it. If you want to know some specific points, you can pull them from the graph. So when x is 0, the y's are 3 and -3. When x is 4, the y's are 0. So you can solve it for y to graph it, see what the graph looks like, and then also look at the table to get some points. Okay. Hyperbolas look like this. They have your equation here, x squared minus y squared equals 9. What are the lines of symmetry? What are the domain and range? So going to be asking, you're going to be seeing those as well. Same thing though, if you want to graph it, you can choose points, manually substitute them in, or it might be faster to just solve for y. So y squared equals plus or minus square root x squared minus 9. So we'll go here, square root. And then the negative. Okay, and you can see what it looks like. Also, take a look at the table, okay? But notice that there's some errors here. So there are some points on the graph that are not included in the domain. So hyperbolas, they have two branches, okay? The center for this one is right here. It happens to be around the origin. And then there's two lines of symmetry. We have the y-axis. So if I imagine folding this along this line, these points would exactly match up. And there's a second line of symmetry along the x-axis. So if you folded it this way, they would also match up. And then the range would be all real numbers. Okay, so if you kind of look at each point, the range is all the possible y values. There is a y value at every single point. And then the domain, which are the possible x values, that one is what has some restrictions. So if we look at the x-axis for our domain, okay, there is no, the numbers between -2 and -3 and 3 are not included. There are no points on the graph. So our domain are all of the numbers that are less than or equal to -3 and all the numbers that are greater than or equal to 3. So only these x's have y values. These ones here are not included in your domain. Okay. Backtracking a little bit, the same questions are going to be applied to your other shapes. So where is the center? Where is the axis of symmetry? And then they sometimes ask you about the x-intercepts, the y-intercepts. So these would be your x-intercepts. These would be your y-intercepts. And then what the x values are included in the domain. So for this one, we have from -4 to 4. Anything outside of that is not part of the circle. And then your range only goes from -3 to 3. Anything above or below that is not included in the circle. And the same for this circle, where is its center? For the circles, every line is an axis of symmetry, right? I can fold this on any line and they're going to match up. And then again, your domain are the x values are only included from here to here, and your y values from here to here. So the x and the y-intercepts for the circles, these are x-intercepts. These are also the margins for my domain. These are my y-intercepts. Those are also the margins for my range. Okay, sorry to backtrack a little bit. And then going through identifying graphs. Okay, you want to know what this shape is. So this is a hyperbola. It has these two, kind of call them branches. Its center is here at 0, 0. You have an x-intercept at -2 and an x-intercept at +2. There's no y-intercepts. Okay? This is what my y-axis, and the graphs never touch that line. Our domain are all of the numbers that are less than that -2 and all the numbers that are greater than +2. This spot right here is not included in the domain. And then the range is all values. Every one of these y's is going to be hit at some point because these graphs just keep going and going. For our ellipse here, Okay. It also has a center of 0, 0, has x-intercepts at -6 and 6, and those are also going to be the boundaries for our domain. And then y-intercepts at 4 and -4, and those are also going to be your boundaries for your range.